have to come to this form. And look, here's nitrate. So nitrate is NO3, and the charge is a -1. As I promised, I'm going to record or show you how to do the odds for the worksheet that was your homework. Just because, we're learning different languages. 1, 3, 5, 7, 9, on and on. They're called odds. If it's 2, 4, 6, and on, those are called evens. That's one of those words I didn't know. So let's start first with potassium chloride. So our first rule is write it as you read it. So for potassium, that is K, and chloride is Cl. Then you're going to assign oxidation numbers. For potassium, it's +1. For chlorine, it's -1. Then you drop the signs, crisscross applesauce, and what do we get? We get KCl. Do we need to put the ones? No, because they're really invisible. Okay, you don't need to put the ones. Alright, so let's look over here. Aluminum bromide. So aluminum is Al, bromide is Br from bromine. Then we're going to assign oxidation numbers. Aluminum is in group 3, so it's a +3. Bromine is in group 7, so it's a -1. Then we drop the signs, crisscross applesauce. So I get aluminum. How many? Just 1. And how many bromine? 3. And that's aluminum bromide. Okay, come down here to sodium nitrate. So we write sodium. Sodium is Na. Nitrate. Okay. Nitrate, if you look on your ion sheet, it is NO3. And it also tells you that its charge or oxidation number is -1. Sodium is in group 1, so it is a +1. Then we drop the signs, crisscross applesauce. So how many sodium do I need? Just 1. And how many of the total nitrates do I need? Just 1. So I can write it as NO3. So that is sodium nitrate. Alright, let's do ammonium chloride. Again, if you look at the ion sheet, ammonium is the only positive polyatomic ion we have, and that is NH4. It tells us that its charge is a +1. Chloride, she's a bride, so that's chlorine, and she's in group 7, so her charge is, or oxidation number is -1. Next thing we do is drop the signs, crisscross applesauce. So how many of the total ammoniums do I need? Just 1. And how many of chlorines do I need? Just 1. So this formula, NH4Cl, is ammonium chloride. Alright, so now I want to talk about, this is an even, this is an odd, but when you have ferrous and ferric, this is iron. This is also iron. Ferric is a +3. Ferrous is a +2. If you look on your ion sheet, it tells you that. You do not need to memorize that, but what I want to show you is, let's do the ferrous sulfate first. So we've got ferrous, which is iron. So if I look on my periodic table, iron is Fe, and we already looked it up, and it is a +2. Sulfate, again on your polyatomic ion sheet, that is SO4. It tells you that the charge is a -2. So then I drop my signs, crisscross applesauce, So how many iron do I need? Total of 2. How many sulfates do I need? 2. But what do you see here? What is that last rule when it comes to ionic compounds? Can I reduce? Yes. Okay. So it's going to, those 2's are going to cancel. So the formula is going to be FeSO4. You don't need the parentheses because you only have 1. Okay? So let's come back over here to ferric chloride. So ferric, I told you, is iron 3. So I write Fe, still iron, and the charge is a +3. Chlorate, if you look on your ion sheet, that is ClO3, and it is a -1. So let's drop the signs, and then crisscross applesauce. So how many iron do I need? Just 1. And then how many total chlorates do I need? I need 3. So I need to show that I need 3 of all of those. Parentheses, and then that's subscript on the outside. Okay, so I need 3 of those chlorates. That is ferric chloride. Okay, let's look down here at zinc chromate. So if we write it as we read it, zinc is Zn. If you look on your polyatomic ion sheet, you'll see that chromate is CrO4, and that's a -2. And even zinc, they have it on there, and it is a +2. Okay, so I need to drop my signs, crisscross applesauce. So what do I have? How many zinc do I need? I need 2. I know some of you are saying, but it can reduce. Hold on, let's just do it this way. If you know that it'll reduce, you're awesome. There's some people who are still learning, so let's just work with that. So we need to show that we need how many of all these chromates? We need 2 of them. So I do parentheses, CrO4, 2. But what do you see, my people? What is it? It reduces. So what can I do? If I reduce that, then what do I have? Zn. Do I need the parentheses if it's just 1? No. CrO4. Zinc chromate. Alright. Over here. Mercury 2 phosphide. Mercury 2 phosphide. Mercury is Hg. It's a metal, but is a liquid at room temperature. And this Roman numeral 2, that tells you the charge. It tells you that that's a +2. So that already is a +2. And phosphide, she's a bride, so that starts off as phosphorus. So that's just going to be P, right? That looks awful. Hold on. And phosphorus is in what group? It is in group 5. So it has a charge of -3. Then I need to drop my signs and crisscross applesauce. So what do I have? How many mercury do I need? I need 3. And how many phosphorus do I need? I need 2. And that is mercury 2 phosphide. Okay, so while we're here, I just want to do the tin-4 sulfate. So tin, if you look on your periodic table, is Sn. It is number 50 on the periodic table. And what does this 4 tell you? It tells you the charge. So tin has a charge of a +4. So already you know that that's a +4. And then we have sulfate, which if you look at your ion sheet, that is an SO4, and it's a -2. Okay, the next thing we do, drop the signs, crisscross applesauce. So how many of the 10 do I need? I need 2. I know. If you know how to reduce, just keep going. How many of the sulfate do you need? Well, we need 4. So I put parentheses, SO4, 4. But some of you smarty pants are saying, but I can reduce. Look, here's a 2 and a 4, and I can pull out a 2 from that, and that's going to be what? SN, parentheses, SO4, 2. That is 10,4 sulfate. Okay, so let's come down here. We're doing the odds, still doing the odds. Okay. So, PB. So I look at my periodic table, and when you're writing the names for the compounds, you really need to use your periodic table. So look up PB. What is the atomic number of PB? Well, that's 82, and its name is lead. So let's write lead. And first, one of the things I told you to do is if you underline the metals. Well, if we go through and we underline the metals, okay, that's not a metal, but this, you get the idea. These are all metals. They're all metals plus nonmetals, which means that they're what? Ionic. Okay, what does ionic mean? It means no prefixes. Okay, no prefixes. So, it is lead. And it is oxygen, but she's a bride, so she's going to be oxide. The only other thing that we need to do is we need to figure out which lead this is. So this is one of those that's a little bit more difficult. Okay, so we know that oxygen is a -2, right? Oh my goodness, sorry. So we know that this doesn't have a 2 down here, does it? So the only way that this would not have a 2 is if that had a 2 there. So this one came from here, so that had to be a +2, right? So that means that this is lead 2 oxide. That's a little picky. I may not count off for that. I don't know if I'll give you any of those, but I just wanted to show you what we do. Okay, so let's do number 3.